All right. Why don't we start? I can give a couple of definitions of what people believe an agent is, and then we start riffing on top of that. Okay. So I'm going to go by memory, so pardon me if I forget something. First one I'm going to use is from Harrison Chase, the founder of LangChain, and he says AI agents are software systems where large language models impact the control flow of the application. So until before agents, basically you have deterministic code most of the times, unless you have crazy bugs. And now when you build an agent, you have an LLM, which is fundamentally probabilistic, and that LLM can decide which is going to be the next action that the application takes. And another definition that I like that I think was floating around on X, and I'm borrowing this from Wix, is agent equal LLM plus memory plus tools plus a while loop. And I hope I didn't forget anything in that equation. I think I like both of them because they describe like two different main aspects of the problem. On one hand is you want to think of an agent as, again, a non-deterministic piece of software. On the other hand, a lot of people still think that an agent is purely doing calls to an LLM and figuring out how to make progress. In reality, it's quite a lot more than that. You need memory, which is the concept of you want to make sure that every single action that the agent takes, you actually don't discard everything that happened before in the trajectory. You need tools because you want your agent to interact with the external world. The external world could be anything. You could be calling an API, you could be running code and then see if there are errors in your code. It's a way for the piece of intelligence, which is the LLM at the core of the agent, is capable of interacting with the external world. And last but not least, you want a while loop, or like you want a way to iterate, because the unfortunate truth of building agents is that they never get things right at the first shot, at least the vast majority of times. And likely LLMs and the more advanced ways in which we're building agents allows you to make some level of progress at each step. So that's why you want to keep attempting until the outcome is successful. So speaking of while loops, I think we got the best person today to talk about them because you work on React, you work on a lot of different architectures, and probably React is the...
I didn't recognize while loop is associated with React.
I just came up with it.
I kind of got it.
There you go.
I actually kind of agree with both of your definitions. Mm-hmm. I think in fact, like different people definitely have different definitions, and that's because people come from different backgrounds.
Of course.
And I can tell like at least there are three very relevant backgrounds for how to define AI agents. So one background is like software engineers, right?
Yeah.
Like software engineering. From the perspective of software engineering, like Harrison was a software engineer, so it's very natural for him to have that definition, sure. Right? So in that perspective, it's just another code base, but you just have calls to LLM, which is a very special new function in that code base. And then you have to deal with all the problems associated with that function. I think that's my very reasonable view.
Yeah.
I think another view come from like an NLP, or you can say language model, right? Like from RN, SIG to SIG to GPT-1, GPT-2, that kind of line of tradition, right? Mm-hmm. And in that line of tradition, the first thing that's agent-like is tool use, right? You can imagine like Transformer, that kind of stuff. Like you have some external tool that can give you some external feedback, no matter if it's translator or calculator. That's the first step ahead. And then you have, like reasoning, and you have memory, you have all those piecewise things, and then start to group together into this big LLM-based system, mm-hmm. where LLM is the core, and then you have all those different things that's supposed to augment LLM. I think that's a very like language model oriented.
That's true.
Yeah. It's also very empirical and kind of piecewise view. So I think personally I like the third view most, which is from the history of AI agents, because that's the one with arguably one of the like longest history. From 1950s, people started to think about AI agents as like a human-like intelligence, and we have like rule-based systems like Noel-Simon, computed architectures. Mm-hmm. We have RL agents. We have all those different kind of agents, and I think a lot of things become simpler if we view this wave of LM agents through the history of all the AI agents.
Yeah.
And I think in that view, so the first important thing is environment. Like all the agents will have to have an environment interact with, right? The agent give action to environment give feedback to the agent. That's the most canonical view of agents. And like if you're an Atari agent, your environment is Atari. If you're a coding agent, your environment is IDE. I think the second biggest concept is memory. Like you said, like because we have context window, we have ways of LLM, we have all those information storing devices. You almost have an internal environment, and that's very different from traditional agents. I will explain later maybe throughout the chat. And then I think once you have those external environments and internal environments, you have an action space, which includes like both external actions, like
tools,
like tool call or whatever. You also have internal actions. I call reasoning an internal action. Basically, you can imagine reasoning is like you have a working memory in your head and you just try to append some information into that working memory. That's like interacting with the internal environment.
I think I forgot reasoning from that equation before. No, I think it was 4 elements, so reasoning was one of them,
Right.
You're spot on.
I think once you define the action space, then you just need to define what is called planning or decision making, which is how do you choose the action out of the action space.
Yeah.
So this is a very abstract view, so maybe it's not as relevant to practice, but I think that's the more beautiful kind of way to think about this. You have a like symmetry between external environment and internal environment, and that's really the motivation of the React paper that's coming out of it.
Yeah, you're right. It seems like we've been working on this for 70 years. Now we just have a better piece of intelligence to put in the system.
I think from the history, we have been always focusing on external environments, right? Whether we solve Atari, whether we solve Dota, whether we solve Go. But I think the internal environment part is kind of omitted because the internal environment is usually just a neural network or is a piece of code. It's really not that complex. You don't have a lot of autonomy over that. But only in this LM agent era, like the agent can actually decide a lot about, what I want to write into my own memory, what I can do to change myself, that kind of autonomy. So that makes the thing much more interesting.
I see. So your point is the environment is becoming the internal environment is becoming much more powerful than it was before.
Yeah, it's kind of like the difference between like a little rat versus human, right? The rat is just operating by instinct. It's kind of hard to argue you have an internal environment because the degree of learning or degree of like what they can write down to their memory might be limited compared to humans, right? But for us, it's very interesting because we can think, and think is a very special type of action. You can think about anything, and then it doesn't really change the external environment, but it changes your internal environment. If you think about something angry, it will change your internal state.
Of course.
And that might change a lot of things. So I think that's something very human-like in some sense.
Yeah, and because we have system to thinking that previous models didn't have almost at all. So speaking of, given that you're at OpenAI, it seems like O1 is probably like the first attempt at bringing that into modern LLMs.
Yeah, I think O1 kind of shows one point, right? Like thinking can be really long. And that's really, I think there are two differences of thinking versus other actions, right? Because for humans, you can jump, you can think, you can, punch someone, there are all sorts of different actions. But what's really special about thinking is twofold. So first, it doesn't really change the external world immediately. It just changes your internal state, right? It doesn't really change anything besides yourself. And second, like you can think about anything. It's a very huge space. You can think about a word, you can think about a paragraph, you can think about a passage. You can think longer to get more like decision making or power or capacity to decide things, right? And I think O1 kind of shows that point. Basically, the space to think is just infinite and it can be arbitrarily long. That's very different from playing Go, for example, because you only have 361 actions. But for thinking, it's combinatorial, right? You can think about infinite things. And really, through this kind of long thinking, you get to really leverage the power of that infinite space in some sense.
Yeah, that's very true.
Sorry, I make the conversation more philosophical.
No, I enjoy it. Yeah, I enjoy it. Do we want to go back for a second, like explaining how React maps to that while loop I was talking about, just so that everyone knows what are the fundamentals to build agents, and then we can take it from there. Yeah.
So the way I think about this is like all the traditional agents, like people have been building for decades. The basic paradigm is like this. Right, you have an environment, you have an agent. The agent will issue an action to the environment. The environment will give you an observation back. And essentially, the agent maintains a context, which is all the previous observations and actions, right? So given this context, the job of the agent is to predict the action to give to the environment next, right? So if you're playing Go, like the context is just all the like turns and all the like how the board look like across all the time, and who takes what pieces, right? All of that information, that's the context. And then you're just trying to, based on that, predict the next action, which is where should I put
the next one, yeah.
stone, right? So, so if you think about this in like implementation, it just looks like a trajectory where you have observation, action, and you're kind of essentially just trying to condition all of the previous stuff, trying to predict the action. And then you kind of realize that's just very similar to what language model is doing, right? Because you have this appending context window, and you're just trying to condition all the context to predict the next token or next action, right? And really what React adds to this is just that you have this capacity to think, which is a very special type of action. It's almost like a comment in a code, right? Because it doesn't really change the function of the code. It just kind of changes how you will write
it.
It just changes context.
And maybe we should debunk the fact that it looks like there is a lot of hype around coding agents, and I'm part of the problem in a sense, because that's what I've been building in the last especially a few months at Rapid. But we should.
Encourages for you to say that because
like at least I admit my guilt. And you also work on Bench, and you work on a lot of the building blocks that we are using today, like to build coding agents. But the truth is, I wanted to start from this more generic definition because by far that's not the only type of agent that can be built. The reason why we do it is because LLMs are exceptionally good at writing and editing code. I would say more than other capabilities that they have. And at the same time, building a powerful coding agent is kind of like a holy grail to be like some level of intelligence, but it doesn't mean that that's the only application area of agents. And there are different tools that you can give access to an LLM. It doesn't have to be necessarily running your code. It could be calling an external API, or it could be like taking some specific action in your software. And I see a lot of hot debates online where people try to argue if something is an agent or not. Like I hope the framework that we kind of went through is a good starting point to understand if that's the case. And like I think that one of the core features that it needs to have is this reasoning by means of React or like anything else to actually make progress and reason what should be the next step in the plan.
I think it's really about like the degree of autonomy of the agent, because you can even argue something that's very deterministic and very like fixed, right? Like a rule-based agent. Like I always just take that. Like you have a rule to play Go, you can also call that an agent, even though it's maybe not a very good agent.
Yeah.
But I think React is more about, it's really, you can argue, one of the most autonomous form of agent, because it really gets you choose what it thinks and acts in a very free-form way, aka like LLM sampling. There's literally kind of no constraint besides the language model itself. You can argue like some other things that have more constraints to that. You can also argue it's a form of agent, but it's just less autonomous kind of agent. That's how I think about this. But I think that the obviously you use abstraction because it's useful. To some degree, if it's too far away from autonomous agent, it's probably not very useful to think about those things in agents.
Yeah, I think there is always this tension between people like us that we come from a research background, and we always hope to strike full autonomy as soon as possible. Because again, that's kind of the mindset that we start with. You want to try to hit, the most ambitious goal. The truth is, in that spectrum of autonomy, there are a lot of interesting things that can be built where you are far less autonomous than fully. Right. And what I'm building at Rapid is kind of a middle ground where we try to keep the human in the loop as much as possible. And the reason why that's useful is, first of all, it leads to a completely different user experience. You're not building a system that maybe runs for half a day and sends a notification, and if you didn't do any progress, you're actually frustrated by it, and you felt you spend a lot of money for no reason. Because as a side note, AI is very expensive today, as you all have realized. And at the same time, it also allows you to correct what the agent is doing. So I think one of the main curse of building agents is the fact that through a very long trajectory, the compound probability of the agent going in the wrong way gets very high. And having a human in the loop that checks if the work that is being done is correct or not is actually a very good trick to avoid that the trajectory goes astray.
Do you think it's kind of similar to the situation of autonomous driving?
Yeah.
L2 versus L4.
Yeah, I don't know exactly where we are now. Definitely, we don't have an L5. Even in the world of coding, we don't have an L5 coding agent. And I wouldn't know exactly where to put, for instance, a Replit agent today. I hope we are somewhere like between L2 and L3. That's my
I think one subtlety is that like driving is a simpler problem in terms of goals specification because you have two places. And that's specify the problem kind of.
Yeah, the planning is easy.
Like I think the problem definition is easy.
Also,
like A and B, and then you go from A to B. But I think for coding, maybe at the end of the bottleneck is how to define a problem. Sometimes that's even harder than how to write the thing. So therefore, the bottleneck is almost always the product manager or whoever that defines the problem.
Yeah.
So just one comment about the difference here.
No, you're right. Like we analyze the prompts that people submit to Replit agent, and the distribution is very interesting. There are a lot of them are just 1 or 2 liners, which totally makes sense.
Is there like a distribution of like what people use AI for coding more? Is it front end? Is it back end? Is it some kind of?
We started as a full stack agent, so usually people try to build entire web applications. Okay. But the moment we made it also powerful just on building front ends, we're getting a lot of requests like that. But also the other interesting insight is it looks like any other power distribution where there are a few people that write very long prompts in Markdown, perfectly structured. It looks like something I read from good PMs in companies. and they hope that we could actually accomplish everything that they write in there.
Maybe that's just from the PM.
Yeah, I think so. But it makes me feel, the input prompts.
The high expectations.
Yeah, exactly. First of all, it's high expectations, which are very hard to set. The hype is so big that you can't always fall short for expectations. But then at the same time, there are, again, in the case of coding, people that never learn how to do it and don't want to learn how to write code. And then when they actually see something running based exclusively on the natural language prompt they use, that's really magical. And I heard feedback directly from them.
Do you start to have some like heavy users that is like using it all the time?
Yeah, we have people that tell me after 3 weeks we launched it, someone clocked 100 hours working with the agent. It's like a full.
Is it like
full-time job?
Full-time website builder?
Yeah, it's a full-time job. But again, I think that the fact that we didn't attempt to make it fully autonomous, because I think today is a pipe dream to make that happen.
It's just much more practical.
Yeah, it's much more practical, and you also have the capability of like reverting and then deciding, okay, the last 2 minutes were useless, or my prompt was too ambiguous for the agent to understand what I wanted to do. So let me go back to the whiteboard and describe.
I think it would be interesting to look at a heavy user and see how the prompt evolved, just to see like
that's a good point. Yeah.
What has the user learned?
Yeah. How do they learn?
Tricks that is effective to. Yeah, it's kind of like a natural case of like a masterclass. They become very heavily using that.
Yeah, you're right.
Psychology.
I've been getting this question a few times. People ask me, how do you train your users how to best prompt an agent? And the truth is, I absolutely have no clue.
Right. You just have to try it out.
You just have to try it. And I think we're teaching people how to use agents in general by allowing them to try. And then they figure out over time the limitations and the capabilities of it. And I feel this is a problem in general with anything AI today, where even a chatbot is very limited in terms of user experience. You try it and then you figure out what it does well and what it cannot do.
I know one original like motivation of Replit is like to make it easier for everybody to try coding, or
correct,
make it easier for everybody to learn coding, right? Like I guess I'm wondering like with those AI features now, would it be easier for people to learn coding?
First of all, I think the mission, given what's happening with AI, moves from enabling them to learn how to write code efficiently to actually allowing them to create software, regardless of the background where they come from. And I found it very exciting. Like when I joined, I thought the mission would have been going to what we have today, but it would have taken, I don't know, like a decade. And I tend to be very optimistic about AI. Like I've been doing this for several years, but I didn't expect the evolution to move this fast. Regardless, the fact that now for simple applications, you don't really have to learn how to code. I don't think that's the most important mission we have at the moment, like teaching how to write code. And the interesting byproduct is that agents can also explain what they're doing step by step. If you surface the reasoning tokens, then a user will understand exactly why the agent has made certain choices. And when we first started to work on that, had this false assumption that people don't care about what the AI is doing under the hood.
They actually care.
Yeah, like I forced quite a lot the direction of the user experience to be very elegant and minimal and transparent, and we were just saying, okay, we created a file.
They just care about the final product with the website.
That's what I thought.
They actually look at all the trajectory and the reasoning.
I was wrong. And then there are quite a few people, especially those that are more advanced or they want to learn while using the agent. They keep telling us, why don't you show us exactly every single step and why you made that choice? And it's kind of hidden in our UI. Like you can click a button and see what were the thinking tokens behind a certain action. But I thought people care about them. But yeah,
I guess there's motivation for like both pros and laymen to both look at the trajectory, right? Because for professionals, you would by default not really trusting that technology because you would think this is definitely not as good as me, right? So,
of course, yeah.
So you want to look at how it works to make sure it's not doing something stupid or doing something misaligned. You want to like kind of oversee the agent in some sense, right? But for the layman, you probably are curious about what's going on. And you can probably learn from the reasoning, the action, the trajectory.
Yeah, I think so, because they're sitting there. So rather than staring at the screen and hoping for the best,
right.
you want to invest your time in a useful way. So they want to read what is going on. And
maybe that's a better way of learning coding or learning anything.
I think so.
Just read the agent trajectory if the agent is already better than human in that job.
100%, especially on the debugging loops where the agent explains you, okay, we tried to run this portion of code, it broke in this way, this is the exception, that's how we fixed it.
This is almost like reverse imitation learning.
Yeah.
The machine used to imitate humans.
Exactly, now humans imitate what the machines are doing, which is scary, but yeah. It's probably like a very straightforward way to teach people. And honestly, that's how I learned how to write code many years ago. So why not?
If you have a very good programmer that shows you how to debug, how to do every step, how to think out loud. Yeah, that's just much more powerful than any textbook, right?
Yeah, that's why pair programming is so powerful, especially in companies. You want to sit next to someone who knows what they're doing, and then you learn from them. Yeah. So I'd love to see more agents, even those that are not focused on coding, to go towards this kind of user experience. I think that there is value to be gained from there.
For sure. So I'm also curious, like, have you seen any other interesting startups or projects in this era of like AI coding? Is there any other like form of product or like that you think is really cool?
Yeah, I'm seeing a lot of startups focusing on specific verticals. So pretty much the opposite approach that we have now at Replit, where we allow you to build, hopefully eventually will be anything. But on the flip side, there are startups that allow you to take one specific function in a company and replace it or enhance it with an agent. I don't know, think of creating sales leads. Before you had people that were doing that manually, scraping LinkedIn and finding a lot of different resources and then eventually putting everything into a spreadsheet. Part of that work now can be automated. I don't think that the ultimate, at least for now, that they're not going to be capable of replacing what humans do one-to-one. But I think it allows people to move much faster. Like a lot of the tedious work is done by systems rather than by humans. And then humans do the last mile and really bring the value in there. And that's why we see a lot of startups, especially around here, where 10 people do an amazing amount of work that 5 years ago would have been unbelievable. Like I see very small startups with incredible revenues and shipping on a weekly basis, and then realize the team behind it is minuscule. And I think AI is especially agents are playing a big role in that.
I feel like one interesting thing I've been thinking about this is, it feels like nowadays, if you want to build a successful startup, you have to be able to do two things, right? Obviously, you need to be familiar with the technology, the model, but also you need to be familiar with like how, or you have to think about how AI and humans should interact with each other, because I think it's a very non-trivial problem, right? Because the naive approach would be to just do whatever the human job does.
Mm-hmm.
But that's probably not the best way to make human and AI collaborate, especially if AI cannot really replace that job 100% yet, right? I guess one thing that we're chatting before is like take Swimmage as an example, right?
Mm-hmm.
Like the naive way of doing AI coding would be just to replace human programmer by just replacing them with like a coding agent where you could take a very formally specified problem and then you could deliver a pull request.
Yeah.
That sounds like a very natural choice, but I feel like in reality, that's probably, at least now, is probably not the best way AI and human can collaborate on coding, right?
I agree. I think it was WeBench showed us that you can take the work that junior engineers do in company and gradually replace it with coding agents. Mm-hmm. But it not only doesn't give us proof that you can build applications 0 to 1 with an agent, which is actually the case as you've seen with Replit, but also it doesn't allow us as a field to make progress towards that direction. Because like whenever there is a benchmark, then everyone is obsessed to optimize the numbers there, and then they don't work actually on different use cases. So
I think
let's move to
we are 30 minutes now.
Let's do it.
Maybe we should do some Q&A.
Yeah, I love that.
So everyone, feel free to raise your hand. First, before everyone's questions are answered, there's some questions I have already prepared based on kind of people's submission in Discord that I want to ask. How is users who are not coders using Replit different from professional coders, like software engineers? How is that their experience different, or how are they using Replit differently?
People that have no background in engineering, they exclusively use the agent as the entry point. They only use natural language, and they have high expectations of what the agent can deliver for them. For those that eventually learn how to use also some other tools, they tend to do all the edits again through AI rather than typing code directly in the editor. The key difference that we see with people that have a software engineering background is either they take the output of the agent, bring it back into their local editor and keep working on it because they need to do something that we currently cannot do on Replit, or they open the editor in Replit and then do the last mile themselves. So in a sense, they both find it useful, and I see even people that could actually build whatever our agent is building, they still love to use it because it saves them a lot of time. Like personally, sure, I can build a web app. It's going to take me maybe 1 hour. The agent takes 2 minutes. I don't like to write boilerplate code. My time is valuable. Why would I do that? So I think that's the key difference that we're seeing.
I have a question. I'd love to hear your guys' thoughts about goals for agents. Do you consider goals for agent as an intrinsic thing, or something that the environment with the end user pass it in, and how dynamic is agent to go?
It's a great question. Do you wanna take something?
So the question is how to think about goals in agents.
Right.
Like, does agent have a goal?
Right. And how dynamic is it? How what are the kind of just curious.
Do you think humans have a goal?
It's a very philosophical.
Is it something that's installed in your brain, or is it something that you make up for yourself?
I think human has a dynamic goal.
Uh-huh.
At any given moment, there's some purpose, and it changes over time.
Okay. So it's kind of like a temporary kind of reasoning thing in your internal memory, I guess.
Correct. If I were to kind of model myself,
Yeah. I think it's a very interesting conceptual question, and I think it somehow depends on how you train the model, right? Or in the human case, how you update your own brain, right? So if you are engaged in a very reinforcement liking kind of activity, right? Like you have a goal and you keep practice toward that. It becomes a very closed loop thing. Then it's very different from you have a goal and then you just do open-ended inference and in a very open loop way. Not sure if that addresses your question.
Can I just double?
Sure.
I want to kind of push you a bit
Sure.
because there's a middle ground, a fine middle ground between being a poetic humanist and being like an overly reductive technologist and wanting everything to fit into the current paradigm.
Mhm.
And I hear him talking about, well, what is the space between the current, RAG-based LLM infancy approaches and any model of higher intentionality that we think exists at least temporarily in humans. I left here for a minute because I had to grab a coffee. That was definitely guiding my behavior for at least 3 to 5 minutes there. How do you think through the gap between where we are now and more capable?
Yeah, I think the concept of goal is only useful if you can learn from it, right? So, if you aim to get a coffee, right, and then somehow you couldn't get it, you can learn from it. Even if you get it, you can somehow still learn from it. I think the problem of today's LLM-based agent is that the goal seems to be more of a made-up thing because it couldn't really learn from whether it achieves the goal or not, because it's an inference time thing, and you have this very clear separation between train time and inference time. That's very different from human. Right? You don't have a training time and inference time. You always are in both modes. I think conceptually that's one of the biggest questions we have to think about, like how to somehow engage agents also in some kind of training mode so that like whatever experience that has occurred is somehow useful for its own self-improvement. Right now it just doesn't improve, right? Like you do something and then you reset and it's the same thing.
Yes.
So I've got kind of a related question to all of these. Like, one of the things that we're seeing, whether it's for reasoning or agents, is that at the end of the day, like you need really good traces. Whether reasoning traces that are domain specific or agent planning traces that often need to be domain specific.
Right.
It could just be where we are today that we should go collect this very hard to gather domain specific data. Do you think we're stuck in that domain, in that space for a few years? Do you think eventually models will be generalized without it? Like how do you think of whether it's reasoning specific or agent specific traces, like how important that is in the short to medium long?
Yeah, I mean the traces are obviously very important, right? Because so I have a follow-up paper of React called Fireside, and the idea is exactly you should generate a lot of traces and then you should train on that, and that makes your model better. But I think an analogy I want to make about this is like imagine the human world where every day you wake up, your memory resets. You don't really learn from yesterday. However, you leave a lot of traces on the internet, and then you can somehow train a better human by training on all that traces. I mean, it could probably still work, but it's probably not very good because leaving a lot of traces and then learn a big model together, it's kind of like a very horizontal kind of thing versus what you learn every day in your own life is a very vertical thing. Right? So I'm not sure if doing one thing can replace the other thing totally. Like maybe, I think as a big research agenda, we still need to figure out how to make language models not to reset every day when it wakes up or every task.
You're stuck in the world where we're collecting very narrow domain specific, specific traits.
But it's just apparently very hard if you have an API that you call and you have a separation of training time and test time. But I guess it's very hard. Yeah.
People have been doing research on continual learning for years, and it's still not nearly remote to get in production for large models.
I think it's just very hard to scale it up.
Yeah. That's the problem.
I was going to ask about your predictions for the future. So you mentioned being surprised by how fast things have gone in the last few years, and you thought it would take 10 years to get to where you are now. I'm curious for both of you, like, what you think things will look like in a year. Like what will be the impressive things that as agents can do a year from now that they can't currently do?
I want to see how the combination of scaling inference time compute an agent is gonna look like. I think O1 shows that it's in the realm of feasibility, but it's not a model that is easy to use in production today. It doesn't have function calling, it doesn't have system prompts, it doesn't have a lot of bells and whistles required to build agents around it. That's what I'm excited to see in 2025. I know it's coming, I know that several people are working on that. It's gonna force us to rethink how we build how we build agents. Because most of what we are doing right now were single LLM calls with limited amount of reasoning. And then we were basically connecting them together by means of calling tools or doing React or other like fancy approaches. And I want to see how we're going to be building agents where a model is allowed to reason for like several minutes. I think it's going to be exciting, but I cannot tell exactly what it's going to unlock. Maybe you know more because you see it in action internally.
I think it's going to be, quote our CEO, right? I think agent will be big in 2025. I think like on a high level, like people have been doing imitation learning for many years, right? Like you can argue pre-training and SFT and even most of RHF is some kind of imitation learning, right? RHF is just imitation learning with a weight kind of.
Yeah.
Like O1 is like really a new era of reinforcement learning, and you can argue that's fundamentally different for agents. So I think there'll be something exciting coming out. But I think still the biggest question is, I think there's somehow two questions, right? One is the question of intelligence or capacity or capability. And the second question is like, how good it is to find the product market fit or to find the real world application, right? How useful it is for your application, right? I mean, like take Anthropic's computer use as an example, right?
Mm-hmm.
I mean, the model, like just the model itself, right? It's probably very hard to imagine like what's the use coming out of it. But for example, you guys have this
we integrated
demo.
Yeah.
I think somehow building better models and finding good ways to use model are kind of equally important if the latter is not more important than the first model. It seems that the latter is really the bottleneck, in my opinion.
I agree.
Like we can already do more with current models somehow.
Yeah, we could stop model development today, and I think we're going to have another few years of building on top of them in a smart way. I know we're not going to stop here. So I think for people that are building agents, it's kind of frenetic as much as it is in the labs where they're training models. The other thing that I expect from O1 style in 2025 is perhaps higher reliability per step, in the sense that we are talking about traces. You could think of taking a previous trace that your agent has created where it solved a specific bug. And now you put that trace in context, you allow a model like O1 to reason for long. And I do expect the failure rate of the single step to become much smaller. That's probably is in my wishful thinking for 2025 that is going to happen.
I have a question about kind of product market fit, since we're on the topic. So earlier, we had the founder of Cursor come here and give a talk and demo on Cursor, and we asked him a lot of like product market fit, user experience questions. Mm-hmm. What he essentially said is that he is building Cursor for himself. Like when he's building Cursor, he's like, the fact that a lot of people who are not engineers like to use it is just a nice side effect that come from like them building for themselves. So I'm curious for Riplet, who are you guys building towards? Like, do you guys have a target audience? Do you have a core segment of people you're going after?
Yeah, we're not building for us. And I think that's a very hard exercise to do when you're a developer and you work on something that looks like a developer tool. Our target is what we call citizen developers. So people with an eagerness to build software, but without the necessary background. You can put them on a scale, like some people are good enough at understanding maybe an error message in the console. And then back in the days, they will copy paste it into ChatGPT and ask the model how they will fix that. And some others maybe are able to add these small snippets of code. But our North Star is to go down the spectrum to people that don't even want to look at code. So it's the complementary user base compared to what Cursor is targeting, which is great because I think we need more powerful tools to make today's developers more efficient. But at the same time, I want to see the equivalent of what, say, Canva did for design. I want to see the same happening for software. Like I don't know how to draw. I'm a terrible creative person. If I go on Canva, I can do something decent to sign a birthday card. I want the same thing to happen with software. And that's what we're targeting.
Oh.
I have a more specific question.
Sure.
Consider like this very ambitious sort of eval. You give an agent a giant fleet of GPUs and a long time, like a month, and you say, here's a bunch of papers, I want you to replicate all of them. Get back to me when you're done and show me the papers you've written as a result. When will it be able to do that? Are you thinking like a year, 10 years, 5 years, 100 years? Like, I don't know.
How good do you want the paper to be? Because there are a lot
Just replicate, just replicate. Not like fancy new science, just like, do the due diligence and
replicate the code base necessary to implement that paper.
re-implement all these papers.
Depends on the paper, and I know it's an unsatisfactory answer.
What's the batch?
I mean, you'd be surprised. There are a lot of deep learning papers, especially like pre-LLMs.
Depends on how solid the repo is.
Yeah, exactly.
Okay, take like all the papers from like 2023 or something, and Europe or something like that.
Okay.
And then be like, this batch.
Maybe the problem is the API is not available anymore. Like they're using
So, yeah.
GPT 3.5, whatever.
And getting the compute to do this.
I have a question about agentic environments. How do you see that space evolving? There's obviously like a proliferation of different environments right now. People, often are using the same ones. Do you think there's a need to standardize it around like one large flexible OSS environment? Do you think there's gonna be like multiple competing ones? How do you think about that space?
I personally think like building agent infra is extremely important, and
Yeah.
I can argue the interface of the environment is one of the most important infra, and I think there are a couple different dimensions that are important. So one dimension is like when you're user facing, obviously, how the interface makes AI human collaboration good. That's the design part. But I think also there's this scalability and reliability part, right? Like how many agents can you run together in this interface? How reliable is it? I think we're way underinvested in that because right now, I guess, agent isn't a very high volume thing. Like everybody is just in the demo mode. But if it becomes very successful and if it becomes very like high quantity, we need better infra for this. Right now, it's like car is just invented, so you don't need very good roads. Whatever road can hold those cars, but if you have like 10 million cars very soon, you need very good high quality roads, and that's a very long term job.
But you don't see any projects trying to build towards it. Everyone's kind of doing their own thing and no one's worrying about the foundation.
I think infra, right? Like if you want to build very high quality, very reliable, very scalable infra, maybe there won't be so many companies that's going to be good at it. I don't know, kind of like browser or some other infra kind of stuff.
Another question. Thank you for bringing up the agent interface. I think there's a lot of actions recently, like browser-based, like Stripe's like financial API. Like I think I consider them all under the agent infra space. Another thing I want to ask is that what do you guys think about pricing in regard to AI agents? This is something that also come up during the Cursor talk. Like, because right now the flat price, like everyone's using the flat price, but obviously that's not going to work long term because some of the users are much heavier users and they're racking up like hundreds of thousands of bills. So how do you guys consider pricing AI agents?
Yeah, flat price is a limitation. I totally agree. And it also has another issue with value capture in the sense that if you're providing a lot of value to the user to the extent that you're saving them time, and we are charging them proportionally to the amount of, say, tokens and CPU compute that they're using, usually there is a huge gap between how much you're charging them versus how worth it is what your agent has created. I don't think anyone out there has cracked this problem correctly. It's probably a bit easier for coding, especially tools like Cursor, where you're targeting developers, they know exactly how AI works, they know how much a token costs, so you can do something proportional. But when you're building an agent that solves, like a problem that you have in a company,
Creative writing,
yeah,
it's very hard to value that.
it's very, very hard to value that. So then you should anchor the value to how much you will be paying that individual in the company and maybe scale it down because it's less reliable. But I've seen any kind of pricing model out there today. So we're inventing the car as we speak right now. We don't even know, I don't know how much like the registration of the car costs. That's where we stand.
I really think that's one of the promises of doing startups because, like, if you're targeting a vertical, you can build a very good price model, business model that can capture the value. For example, like flat pricing, I assume you're talking about something like subscription based.
$20.
$20 per month.
Yeah.
Or like it's kind of like each user is the same price or each token is the same price. But like arguably, if you apply the same for a legal case, the same amount of token might give like a $2,000 value versus if you're just chit chat, it's like $1 value. So whatever startup that can capture those value gaps in the downstream, I think that's a huge opportunity, and that's one reason I think foundation model company cannot really like capture all the values, arguably.
Wait, I'm actually going to follow up on that.
Yeah.
So are you saying that the application startup that either build really good vertical specific AI agents or somehow find product market fit are the ones that's going to capture most of the values?
I'm not saying it's going to capture most of the value, but I think that's one reason like there's a lot of opportunities for the startups.
Yeah, I think there's a lot of value across the board. The fixation that only a few labs will capture the entire value of AGI sounds a bit dystopian to me, and also not grounded to reality.
Capture more of that vertical direction, but foundation model can capture like more dimensions. So that's kind of the truth.
Yeah, totally agree.
I have a question about accelerate agent learning. So my company is Need, and we're working in the cancer AI space. And I'm curious, if you to think about like bootstrap agent in a particular domain, what are the levers you can pull to accelerate learning speed of the agents?
What do you mean by learning?
Learning about the domain-specific knowledge and representation and patterns. And
Like by learning, do you mean like fine-tuning the model or
Yeah.
improving the prompt or something else?
I think in multiple dimensions, I think some of the ways that we are my team think about learning is there is like immediate learning that you can dynamically kind of update your prompt. You can collect examples as you go and to refer to them back, in a real-time fashion. And they're more like long-term, fine-tuning or maybe pre-training. So I'm curious on your thoughts on what are the levers.
I like one of the slides that they use at their developer day, where you see that you can start from in context learning, RAG, fine-tuning, and each one of them brings you like an additional delta in terms of performance. I would start by building within context learning because it takes practically no effort. And then if you feel that your agent is not reliable enough, that's when you start to put additional investment in doing RAG or in fine-tuning. But I don't think there is a one standardized recipe that tells you exactly how to do it today. I've seen a lot of people that are doing specialized agents that require purely context learning. What we do at Replit is purely context learning almost right now. We have done experiments with a lot of fine-tuning on frontier models, but the truth is the real alpha right now is not there. It's in building the infrastructure, 100%.
And one comment about that, right? Like it's equally important to learn, improve the system versus improve the problem or improve yourself, right? Like, if it's not a good problem, then change the problem. Maybe that's the most important learning. Yeah.
We have time for I guess maybe two last questions. So it'll be just you guys.
I'll be quick. I want to ask you a success question, which is in the short run, 6 to 12 months. What are big agent wins you can see happening? And is it very narrow to specific benchmarks where some of the sweet agent bench stuff does really well, or are they things that can be done without a specific benchmark that you think would be a landmark for win for agents?
I think benchmarks will definitely keep increasing numbers, that's for sure. But I won't count that as a big win. I will count a big win if it's actually deployed and bring value to the humans.
Okay, so some company using it, generating revenue, where there's efficiency or new process, where they talk about it and you say, wow, it's amazing.
Right. I would count a big win if it actually creates a lot of good real world applications.
And do you know if anybody is trying right now, or is everyone just still in a very early experimentation phase where nobody has like a clear sight for like one of those wins?
I know some that are profitable.
Okay, so it's just a matter of scaling and announcing, hey, we've done this.
It's a matter of how you do pricing. If it's value-based, then it's relatively easy to make it margin positive. If you play the race to the bottom of pricing it proportional to your tokens, that's a harder company to scale.
Sorry, we had similar questions. You two dodged the last sort of prediction question a little bit. No problem, Tim, but since I'm the last question, I do want to push you to say, if you had one prediction in the next, let's say, 12 to 18 months about which domains, other than pure internet search, right, other than pure online search, agents would prove really useful in, where, from your vantage, do you see the agents being outsized utility in the next 12 months?
It's a tough one.
Besides web navigation, besides coding,
Yeah, besides the thing where it's just pure internet land data, right?
what do you mean pure internet?
Like do a web search or write me a line of code. Besides those two things.
I would expect like one of the most important direction to be better human simulation and better human in the loop advances. And maybe also multimodal. Yeah.
I love your prediction. Let's wrap it up here. That works.
Thank you so much.
Thank you.